Welcome back, PIAC developers. Let's jump right into today's explainer. We're talking about making a massive leap in your AI journey. You know those basic, maybe slightly chaotic local scripts you've been tinkering with? Well, we are going to transform those into a robust, production-ready, multi-agent CrewAI system.
So here's a serious question for you. Is your AI crew actually ready for the real world? Look, when you're just testing things out on your laptop, a mistake is honestly no big deal. But the second you deploy that to real users, man, the risks of unmanaged AI absolutely skyrocket. We're talking wild hallucinations, totally inconsistent outputs, and literally the nightmare of massive API bills if your agents get stuck in some endless loop. You just can't afford that kind of mess in production.
To avoid those nightmares, we need a solid game plan. Leveling up your AI from a fun weekend project to a legitimate corporate-grade team requires 4 chronological steps. We call these the 4 pillars of a production-ready crew: pre-execution strategy, quality assurance, behavioral refinement, and finally, production oversight.
Mapping those pillars directly to CrewAI, our agenda for this explainer covers 4 specific phases: planning, testing, training, and monitoring. Let's just dive right into phase 1.
Section 1 is planning. This is your pre-execution strategy.
Think about how a human corporate team actually works. If you bring a big project to them, they don't just instantly start writing code blindly, right? They sit down, they brainstorm, and they align on a strategy. They figure out exactly who's tackling the front end and who's handling the back end. Well, by enabling planning in CrewAI, your agents do exactly this before they execute a single task.
Without planning, you're stuck in this really rigid, sequential flow. A researcher agent finishes a task and just kind of blindly throws it over the fence to the analyst. But by simply adding planning equals true in your code, game changer. An overarching manager actually evaluates the whole project first. It rewrites and optimizes the instructions for everyone, which creates this highly dynamic, context-aware workflow. And you know what the real magic of this planning phase is? It's the flexibility. Because this delegation is so absolutely crucial, you want your smartest manager handling it. CrewAI lets you specify a planning LLM. So as new models drop, you can easily swap in the best of the best, like Gemini 2.0 or GPT 4.0, just to handle the strategy. This ensures your crew always starts off with the absolute highest quality instructions.
Moving on to Section 2, testing, ensuring consistent quality. Testing is basically your automated quality assurance department. Think about it. If one user asks your AI a question, they might get a fantastic answer. But what happens if 100 different users ask? You need to guarantee that all 100 get that same high-quality response, not just some random, unpredictable variation.
To pull this off, modern testing has evolved big time. We don't just use those old, rigid keyword matching tools anymore. Instead, we use techniques conceptually similar to BERT score, utilizing what's called an LLM as a judge. This means you're literally using a separate AI model to grade the work of your agents, judging the actual contextual similarity between what you expected to see and what was actually generated.
When you run the CrewAI test command, the system iterates through the tasks multiple times and assigns an accuracy score for every single run. So, for example, your researcher agent might hit an average of around 99%. Fantastic, right? But then maybe your analysis task is sitting way down around 91%. This kind of granular scoring pinpoints exactly which agent is the weak link, so you know exactly where to apply more prompt engineering or swap in a better model.
Oh, and here is a super practical pro tip from this source material. Testing requires multiple iterations, right? Which means it's going to eat up your API tokens pretty rapidly. So do yourself a massive favor and specify a highly cost-effective model, something like GPT 4.0 Mini, to act as your judge during these loops. It's just a brilliant way to ensure top-notch quality without completely draining your project budget.
All right, Section 3 is training, getting that human-in-the-loop feedback.
So, you've found the weak spots during testing. How do you fix them? Well, training isn't just letting the AI run endlessly in the background. Think of it more like a senior developer giving active on-the-job mentorship. We are stepping in to actively correct the crew, giving real, human feedback to teach these agents exactly what a perfect output looks like for your specific use case.
Conceptually, here's how the CrewAI train command actually works. The agent runs a task, and then the system literally pauses. A prompt pops up asking for your feedback.
You review the output, tell the system if it's hitting the mark, and provide your notes to correct its path. The system learns directly from this interaction and saves this refined behavior right into a .pkl or pickle file. And that pickle file is incredibly powerful. It isn't just a basic log. It acts as a portable brain. It holds all of those highly refined, aligned behaviors you just taught the system. You can literally take this saved file and load it directly into your live production environment. This ensures your public-facing agents behave exactly how you train them to.
Which perfectly sets us up for Section 4, Monitoring, Tracking AI Performance. Once your AI is actually deployed, you cannot just cross your fingers and hope for the best. Monitoring acts as your HR and operations team. It tracks performance, resource usage, and your budget in real time. If users start dropping off because your AI is suddenly taking way too long to respond, monitoring tells you exactly where that bottleneck is.
The source highlights two fantastic observability tools for this. First up is OpenLit, which is open source and runs locally via Docker, meaning you get total data privacy. On the flip side, you've got AgentOps. This one is cloud-based, so you just drop in an API key and instantly you've got this beautiful, hosted dashboard without the hassle of managing local servers. Honestly, both are incredibly powerful.
Regardless of the tool you end up choosing, these dashboards provide absolutely mission-critical metrics. You can track your total API cost to prevent those dreaded sudden billing spikes. You can see the exact token usage per request, monitor your average run durations, and pinpoint event bottlenecks to see if one specific agent is bogging down the whole pipeline.
And the level of granularity you get here is just wild. I mean, these tools allow you to track costs down to fractions of a cent per run. When you're scaling up to thousands of users, knowing exactly what a single agent interaction costs isn't just nice to have, it's absolutely vital for projecting your budget and keeping your project profitable.
So, let's look at the incredible journey we've just mapped out today. By implementing planning, testing, training, and monitoring, you have effectively transformed a chaotic, unpredictable local script into a managed, predictable, and highly cost-effective AI workforce. You've built a system that is genuinely ready for production.
The tools to do this are right there waiting for you. So my question to you is, which of these 4 pillars are you going to implement in your AI crew first? Seriously, don't wait until things break in production. Take that first step today. Add that planning parameter, run a test loop, and start leveling up your AI. Thanks so much for joining me on this explainer, and I'll catch you in the next one.